All right. Welcome, everyone. Thanks for coming. These are the true diehards of FinTech DevCon. We're Friday. It's almost noon. You're probably recovering from some stuff that happened last night, and we're all waiting around for the rap battle that's happening this afternoon before we go home. But this is fortifying your FinTech stack, safeguarding sensitive customer data with the Data Privacy Vault. So we're going to talk a lot about data privacy, management of sensitive customer data, specifically for a bunch of sort of FinTech use cases. But before we get there, a little bit about myself. I'm Sean Falconer. I'm head of marketing and developer relations at Skyflow. Fun fact that has nothing to do with FinTech or management of sensitive customer data is one of my hobbies, it's a strange hobby, is I like to combine things from pop culture, so television shows, podcasts, with things from machine learning and analytics and data science and so forth. And one of the most popular things that I've done in this strange hobby of mine is essentially predicting the winner of the television show Survivor by using machine learning. So my blog posts about this have received over 100,000 views. I actually do a series of guest lectures for data science students about this project where I use machine learning to do all this analysis. So that's not what we're talking about today. Maybe that'd be an interesting topic. Join the data science class if you want to learn more about that. But what we're talking about today is essentially data privacy. And I think a logical place to start is around looking at essentially this question of why is privacy hard? Why is the management or protection of customer data such a difficult problem to solve? And there's all these companies in the world, very well-resourced companies with lots of employees that they can throw at this problem, have bought millions, if not billions of dollars worth of software that they've invested in this. Yet we still have data breaches, compliance issues, all of these challenges within our industry. And I think a big part of this is sort of goes back to what I think is a fundamental misunderstanding about the nature of data. And essentially, we think of data essentially just as zeros and ones. And the way I like to frame this is as essentially the cheese and the diamond problem. So if we think about something in the physical world of cheese and diamonds, and let's say I'm at my house, you come over to my house, I have some nice cheese in my refrigerator, I want to allow you to have access to my cheese. Why not? It's not that sensitive. I want to be a good host. So you have access to this wonderful cheese. You can break off a piece, have a cracker with it. But if I have diamonds in my house, then obviously I want to be more restrictive about who has access to my diamonds. But if I'm putting my diamonds in my refrigerator with my cheese, it's very hard for me to control who has access to the diamonds versus who has access to the cheese. And essentially the reason is that the rules of engagement for something like diamonds that are very valuable, maybe they even have sentimental value because it's like a diamond ring that's been passed down through my family, I want to really control access to that. And the rules for that are different, fundamentally different than they are for cheese. And that becomes very difficult when we're essentially putting those things in the same place. But that's essentially what we do with data. And if we look at this, I think the takeaway from this is essentially when we're talking about data, not all data is essentially created equal. Some types of data, sensitive customer data, so things like date of birth, email, financial information, healthcare information, simply requires better protection than other forms of data. It's special. And because it's special, it deserves to be treated as something special. And it's the same idea that we understand this principally when it comes to sort of the physical world. So things like my birth certificate or my children's birth certificate, my passport. I don't keep those in the junk drawer in my kitchen with my batteries and my flashlights because if someone breaks into my home and steals my batteries, it's not that big a deal. I can replace batteries. If someone steals my daughter's birth certificate, then I not only feel like I've failed as a parent, but the information on her birth certificate, her name or date of birth, the other information that's there, I can't just simply cancel it and get a new one. It's out forever. So there's major consequences essentially to leaking this kind of information. Yet when it comes to data, for the most part, for the last 40 plus years of building systems, we have essentially just thought of this all as zeros and ones. We kind of put it together, regardless of whether it's customer data or essentially application data or transactional data. So a way to kind of look at this in a little bit more detail, if we take a simple system, sorry for the margin issues, but a simple example problem, a system. So this is obviously overly simplified, but most modern systems have essentially these components. If we're collecting something like a phone number, then that phone number is collected at the application front end. And what we do with that is essentially we pass that phone number downstream through all the nodes and edges of this graph. And we end up with a copy of that phone number in our database, our data warehouse, maybe in our log files, the backups of these systems. And what we end up with is this information essentially copied, replicated, and fragmented throughout this infrastructure. And we end up with this huge sensitive data sprawl problem. So we don't just have one copy of that phone number. We have realistically potentially hundreds or thousands of copies of that phone number. So imagine if you took your passport, and instead of having one copy of your passport that you have maybe in your hotel room or at home in a safe location, you made 10,000 copies of your passport, and then you put them all over Texas, and then you try to protect all those locations. That's a much harder problem to solve than having one copy of your passport that you keep in a safe location. But that's what we essentially do with data. So what are we left with? What ends up happening, and Anshu Sharma, our CEO, talked a little bit about this during his keynote yesterday, is we end up taking a bunch of different products and kind of applying them as security components to each of these nodes and edges. And we kind of take this like chicken and duct tape approach to filling in the cracks within this foundation. So it's like if you have a dam and a crack opens up, you put some duct tape on it, you fill in that hole, and another crack opens up, and you fill that hole. And essentially, this whole thing, as you scale, becomes a completely intractable problem because you simply just lose track of what and where you're storing this information. If you don't know where it is, you don't know what you're storing, then it's very hard to protect that information. It's hard to know whether you're compliant as well. So it becomes this huge intractable problem. And then we're faced with this issue where essentially every week you search Google News for data breach, and you see headlines like this where major companies that are very well resourced are essentially having these challenges. So that naturally takes us to the next question, which is how do we solve this problem? And there's been a number of different companies in their industry that, like Netflix and Google and Apple, who have pioneered different technology that helps solve this problem. And essentially this concept is what we're talking about today, which is the data privacy vault. In this article that Anshu also mentioned yesterday during his keynote, came out last year by IEEE, that talked about the shift that's happening. The article is about the future of privacy engineering. And essentially what they talk about in that article is how we're moving from something called privacy by design, which is a framework for privacy, sort of best practices around privacy, to something that they call privacy by engineering. And the core concept of that allows us to apply this privacy by engineering approach is by using this architectural approach to data privacy through a data privacy vault, where the vault becomes essentially your core infrastructure for customer PII. So we can dig into a little bit more detail about what this really means. Essentially, a data privacy vault isolates, secures, stores, and tightly controls access to manage and use sensitive data. And a big part of this is around this principle of isolation. So if you think about walking into an office building from even 30, 40 years ago, and essentially the employee records, their customer information, the financials of the business, they're not just out on the tables for everybody to see. They're probably, at the very least, locked in a file cabinet, maybe at a bigger business or locked in some sort of vault. But very few people in that company essentially have access to that. And that is essentially like a non-digital version of isolation. And we understand that, again, that concept in the real world, but when it comes to essentially the digital world, we're not always thinking that way. So principle of isolation, you need essentially your customer data isolated outside of your existing infrastructure. It needs to live on the segregated network with very privileged access. It needs to be secure, obviously. This is essentially your customer data, highly sensitive, like we've been talking about. So you need to be using modern privacy-preserving technologies, things like encryption, tokenization, polymorphic data encryption, in order to make sure that you're protecting that data, but still being able to do all the things that you want to be able to do with that information. And if we think about even something like a password, it wasn't that long ago that we used to put passwords in databases in plain text. Eventually we realized that was kind of a bad idea. And then what did we start doing? We realized that the only thing we need to do with a password is check if it exists. And we can check if something exists by salting and hashing it. So we can facilitate the use case of checking whether a password exists by essentially using salting and hashing, a technique for preserving the privacy of that information. And that's the only use case that we need to provide with that. Use cases around PII are more complicated, but using modern encryption and other privacy-preserving technologies, we can essentially have the utility of that information while still protecting it. We need to store it clearly. This is core infrastructure, your customer PII, so you need high availability, throughput. PII or sensitive data can exist in both structured and unstructured form. It could be in a contract. It could be essentially as part of a form that you're taking in from a customer. You need to manage or govern access based around the principles of zero trust. So essentially no one and no thing should have access until you explicitly give them access. And that access should be based on the business requirements of what that person needs to do with that information. So Susie in accounting needs a different level of access than Bob in customer support versus Joe, who only needs to see their singular record of information. And then finally, we store all this data so that we can actually use it. It's one thing to lock it up and throw away the key, but that's not very useful. So how do we access this information? So we, again, need to leverage essentially modern privacy and security techniques to allow us to do things like analytics, perform cloud functions on the data, pass the data securely to third parties. No system exists today solely on its own. We need to be able to communicate with third parties to do things like money movement or payments or KYC or whatever it's going to be. And you need to be able to do that in a secure way, in a compliant way. So if we go back to this problematic system that we were talking about at the beginning, where we have this sort of fundamental problem of the data ends up all over the place, we don't know where it is, we don't know what it is. All this gets simplified when we introduce essentially this approach to the data privacy vault. So what we want to do when we introduce the vault, that's a phone number, is essentially we want to de-identify any sensitive data as early in the life cycle as possible. So if we're collecting that information, for example, in a front end where it's account information, we can send that directly into the vault. The vault becomes the single source of truth of that information. So again, that one copy of your passport versus 10,000 copies of it. And what the vault can do, besides essentially performing all the things that we're talking about in terms of security and allowing you to utilize it, is create a reference. You can think of it like a pointer in the form of a token. And token's a super overloaded term now, especially with LLMs and blockchain and auth tokens and all kinds of stuff. But essentially, think of this as a de-identified form of the original data. There's no mathematical connection between the phone number in this case and the token that's produced, so there's no way to reverse engineer it. It's not like encryption where if you had the key, you could technically decrypt it. And now we can safely pass this token downstream to store it in our database, our data warehouse, within our log files, the backups of those systems. And that way, if someone somehow got into our system, stole the database, all that's in there is essentially these non-sensitive, de-identified tokens. And what we've effectively done is take this entire surface area, de-risked it from essentially the responsibilities of data security, compliance, privacy, and so on. We can offload all that responsibility as engineers to essentially into this sort of privacy by engineering or architectural approach. And that, for me, would be a huge relief because I don't want to have to deal with this stuff anyway. Like, you might not have the expertise within your company to know, how do I do order preserving encryption? How do I support all these different use cases? And it might not even make sense for you to dedicate all those resources to that versus building things that are actually features that your customers are buying. So now what we're going to do, that essentially goes over the sort of core concept of the data privacy vault at a high level. We're going to dive into a couple of specific fintech use cases around payments, around card issuance, money movement, and then we'll take we're going to go through the architecture of what those look like, and then we'll go into some live demos to actually see that stuff in action. All right, so starting with payments, card acceptance. So lots and lots of companies in the world start out doing payments. Maybe they use something like Stripe or some payment processor like that. You're up and running, and very quickly, 10 minutes or whatever, you drop in their SDK, you're off and running. But at some point, a lot of these businesses get to a place where they start to either get annoyed with Stripe because it gets expensive, or they just kind of outgrow it. They want to go into new geos. They want to maybe have more negotiating power, whatever it is, and they want to be able to own that data. But the value that Stripe is providing you or any of these other processors are providing you is you're offloading PCI compliance and providing that essentially out of the box. And that's a wonderful thing, so, as well as essentially the connect to the card networks and so forth. So what we're going to look at is how can we still offload PCI compliance using the vault architecture, but take advantage of some of these, these payment processors in a way that's still compliant, but gives you essentially that business flexibility. So very similar to how you might use an existing service like Stripe, you can integrate your data privacy vault at your application front end so that you can effectively descope your front end. Because if you're collecting any credit card information, your front end also needs to be PCI compliant. And a way to do that is essentially leverage things like a Stripe SDK, or in the world of Skyflow, and a Skyflow SDK to essentially embed what looks like a native form, but it's actually running on Stripe infrastructure or Skyflow infrastructure. So the form fields are essentially iframes into that architecture. And in this case, the credit card is never ever touching any of your systems, going directly into your vault. The vault's going to secure it and essentially pass back this tokenized form, this reference that you can use. And essentially, you can save that safely, downstream in your database. And this is just an example of how this could work. Now, when we actually need to do something like issue a payment, what we're going to do is we can retrieve that token from the database, from our backend, and we can leverage the data privacy vault like a proxy. So, or you can think of it maybe like a firewall, where non-sensitive data is going into the vault. The vault knows how to retrieve that original value, detokenize it within this isolated, protected, PCI-compliant environment in this case, and essentially send that sensitive data over to whatever payment processor, gateway, or whatever it is that you want to leverage. And what this allows you to do, besides essentially supporting this workstream, is really modernize your payment stack. Because now, instead of your data being locked away in a Stripe or some other type of vendor, you own that data within your vault. And that gives you the ability to work with anybody that you want. And to create essentially a more modern payment system where you could be integrating multiple payment processors. So sometimes, essentially, in certain parts of the world, you get better deals, or you can support certain types of use cases or work streams that you couldn't do using essentially one payment service provider. Plus the negotiation power, because now you can essentially flex between whoever you want. Or having backups. It's Black Friday, your payment service is getting hammered. Now you have a backup to make sure that you're essentially providing a really, really good customer experience. All right, so we're going to look at card issuance. Card issuance is very similar in terms of the workflow that's happening, except instead of collecting credit card information, in this case, we're going to collect information about a customer that we're going to essentially use to use some sort of card issuance platform. So in this case, we're going to send data about this person, Joe Smith, directly into the vault. The vault becomes that single source of truth. Tokens get produced back. We can safely send those tokens to a backend, very similar to what we saw before. And now we can use those tokens, pass them to the data privacy vault. The vault can be this proxy, securely detokenize those values, and pass it over to our card issuance platform. And I don't show it here, but essentially the issuer is going to create that card information, send it back. The vault would capture that. And then instead of sending the card information directly as a pass-through, essentially tokenize that stuff on the return. So again, it's acting as this proxy between your systems and essentially whatever sort of fintech stack that you're integrating with. All right, so we're going to look at this last one, money movement. Money movement, in this case, is going to work a little bit different. So in this world, what we're doing is, and of course, there's many, many ways to bake a cake. This is just one example. What we can do is essentially link our bank account through a financial service provider through SSO, so I can connect to my Chase account, essentially, and that's going to create a account token. This is not a vault token or an LLM token. This is an account token that represents my account. So we're not doing anything with the vault at this point. All we're doing is essentially saying that this application can connect to, in my case, my Chase account. Then we can use that account token from our backend and send that through the data privacy vault to connect to this financial service platform to essentially pull the bank account information of that individual. And that account information is going to go into the vault, become the single source of truth for my account information, and then send essentially tokenized data back to my backend. Again, acting as that protective layer between my systems and essentially these external systems that I need to integrate with. And now when I need to do something like money movement, I can just retrieve the tokenized bank account information, call the vault, instead of calling Dwala or Moov or whoever that you're integrating with, as those are just examples, with the raw banking information, I'm just calling it with the tokens, and then the vault can communicate over. And obviously there'd be more than one account involved in this. It could be essentially a business account transferring data to an employee or something like that. So those are three different use cases: payments, card issuance, money movement. There's a lot of other things that you could be doing, but those are sort of the core principles behind the vault integration and being this protective layer between your systems and essentially whatever fintech stack that you're integrating with. Now we're going to go and look at a couple demos and see it in action. So the first one we're going to look at is essentially card acceptance. So this was the first thing that we talked about, was just payments. So I'm going to jump back here, get out of here. So this is pretty simple, pretty straightforward. So we have essentially a form here, which is our card form. And all this card number stuff, even though it looks like it's essentially running on this web page, is actually running behind the scenes on the vault directly, wherever that's deployed. So it's remaining PCI compliant. So we'll put in Sean Falconer. We'll generate some card data here. And you can see the API call here. We're going to submit that. And we're generating these tokens. So these tokens, and we'll dive into this a little bit more in the second demo, but we can essentially generate these tokens using Skyflow in this case, as format preserving, as deterministic, whatever we need to do. So here, essentially the expiry month, year, and name on card are being generated as UUIDs, but the card number is actually being generated as a format preserving token. So I'm actually preserving, in this case, the bin number. So you can see the first 6 digits match the first 6 digits actually in the card, and the last 4 digits are preserved too, which you could use for whatever you need to do, analytics or something like that. It tells you who the card issuer is, plus the last 4 for validation, and then essentially the rest of the numbers are scrambled. And you're in total control of how you want to generate that. It could be a UUID as well. And then, oops, let me retrieve this again. Try it again. All right, there we go. So this is the vault. So we see the raw data. And in the tokenized database, this is essentially the backend system where we're storing that. That could be any database that you want to use. And then once we're ready, instead of calling, in this case, the example is Stripe directly, we're calling the vault directly with the tokenized data. And then the vault knows how to call Stripe for you. So I'm just going to make that request. And then essentially the data from Stripe, the response is going to be proxied back, taking out any of the sensitive data. And then I can store essentially that or process it however I need to process it. So super simple example there. And then we're going to go into a slightly more complex example. So the next use case we're going to talk about is with my company Instabread. So Instabread, it's a fake company, I made it up, but it's like Instacart, but only delivers bread, is the way to think about it. So it's essentially a gourmet bread delivery marketplace. Someday this will exist. So you have, as part of the gig economy, you have essentially Instabread shoppers, and you have Instabread clients. So the clients order bread on their phone. Shoppers go out, collect the bread, deliver it for them. Just like Instacart, but not at all ripping off their name. All right, so there's certain requirements that we need in order to create this system. So it needs to be mobile first. Our shoppers are on the go, so they need their mobile device. We need to collect PII. Essentially, the application we're going to look at is the gig worker sign up. So gig worker needs to create an account. I need to share my information with the Instabread, and they need to essentially know who I am. The Instabread shoppers also need to select what bakeries they're willing to travel to, because I only want to go to bakeries essentially in my, located in my area of work or wherever I live. Banking information, or I need to collect banking information in order to get paid. And then also, this is a modern business. We want to be able to perform analytics on all this data so that we know how to deliver higher ROI, or what features to invest in, or what geos maybe we don't have enough gig workers in. Where do we need to get more gig workers? All right, so the stack that we're going to use in Instabread is essentially the front end is React. The back end is some brightness issues here, but essentially Node. The application storage is DynamoDB. The data privacy vault, Skyflow in this case. And essentially, for money movement, we're going to use Skyflow as a proxy to Moov, and use the Moov APIs in order to do money movement between these accounts so we can pay our gig workers. And then finally, the data cloud is actually powered by Snowflake. All right, so we're going to jump over the demo here. All right, so this is Instabread. All right, so this is my shopping experience. I'm going to sign up. We'll put in my information here. All right, so I'm going to create my account. So normally what would happen is, basically you just collect this data from your front end, send it to your downstream services, ends up in a database somewhere. But what we're doing is exactly what we saw in some of those other, in some of the slides earlier, is we're sending that data directly into our vault. And I've logged into these accounts, but I've been talking too long, so now I'm logged out, so give me a minute. So we'll go into our vault here, our Instabread vault. And essentially, here you can see the information I just entered. And I see, in this case, based on my permissions as the vault owner, even in this case, I'm not seeing any of the raw information. I'm seeing essentially how it's a schema-based vault. So similar to how you would maybe design a database. So, you can create tables and columns and so forth. But built in essentially is all these privacy-preserving technologies and ways to essentially mask and redact all this information. So I can even, one of the sort of core parts of the vault is that besides essentially, it looks, from essentially like a management standpoint, it kind of looks and feels like a database. It's by design, but there's a lot more going on here. And one of the things that the vault can do is really understand essentially PII as a data type. So it's not just like, for example, email. It's not just email as a varchar 32. It's actually email as a data type. So what that looks like, if we look at the actual column structure here, is by default, when I create an email column, is I can configure I have predefined essentially regular expressions to validate that this is actually an email. Or under redaction, for example, I already automatically have a masking rule because it's very common for me to want to mask an email or mask a phone number or something like that. And then through a type of technology that we actually developed at Skyflow, polymorphic encryption tokenization, essentially we can also support not only encryption at rest and during transit, but actually encrypted operations, so we can run queries over fully encrypted data. So I could do something like compute the average spend of my customers by state and run a query like that or an analytical operation like that without actually seeing any of the information. And then finally, I can configure how the data is actually tokenized. In this case, I'm doing a format-preserving deterministic token. So we can actually see what that looks like. So as you saw before, my application database is DynamoDB. So if we look at that, here you can see my Dynamo database here. And what I have in here is just a bunch of tokens. So my name, email, phone number, all these things are UIDs. But the email is actually this thing that still looks like an email, but it's not actually obviously the email. That way, if your Snowflake or whatever it is that your downstream services that you're using are expecting things to look like a phone number or look like a credit card number or whatever it is, you can preserve that format without essentially breaking privacy. And the last thing we'll look at here before we jump back to demo is Snowflake. So all this data is also flowing down into Snowflake, and we'll dive into the details of how that works as well. But you can see essentially this JSON blob here that's being stored within Snowflake as well. So from an analytical standpoint, because these tokens in this case still have referential integrity, they're deterministically generated, I can still run most of my analytical operations directly against the tokenized forms because it doesn't matter if my name is in the analytical store versus a representation of my name. As long as Sean always converts into the same UUID, I can still perform whatever joins and groups and counts and so forth. All right, so let's jump back to our shopper here. So get paid to shop, checkout, then handout, how it works. All right, continue. So these are requirements for shopper. You gotta be over 18, able to lift 40 pounds, eligible to work in the United States, love bread, who doesn't love bread? All right, I meet the requirements. So now I'm choosing which places I'm willing to shop. So I'll hit continue here. And again, even though that data is not technically regulated, I'm storing it within the vault because it says something about where my gig workers probably live. I'm going to probably choose bakeries that are within, driving or biking distance from my home, as well as it says something about where I'll be showing up all the time. So it is a certain level of sensitivity. I wouldn't want, as the Instabread CEO, that information showing up on the front page of the Wall Street Journal or something like that. All right. So now I need to put in my banking information. So let me just grab my Chase routing number. And this is so I can get paid. All right. Hit continue here. And again, that information is flowing into the vault here. And then we're using Moov for money movement. Oh, this always happens. Apologies. Oh, let me grab my phone. Just 1 second. We'll come back to this if the code's not here yet. All right, we'll check back in a minute here. Oh, I got it. 867. So we log into Moov and go to accounts here. You can see this account was just created. So that was done essentially through that Vault Connect to Moov. And if we go back to our studio here, you can actually see what that looks like as well. And essentially, we can connect our vault to essentially any third-party API. So here I have a account creation, bank account creation. I even connected this to HubSpot, completely unrelated to what we're showing here, but essentially you can interconnect that to any third-party API that you want. All right, so congratulations, I'm ready to shop. So through the magic of the demo experience, I've already earned $64 from Instabread. So what I'm gonna do is cash that out so I can perform the money movement. I'm gonna hit cash out. All right, so now if I go back to Moov and I check under transfers, I can see there's a transfer happening from Instabread over to my account. So we've been able to do all of this essentially, all the types of things that you'd want to do as the Instabread developer without ever touching any of the sensitive data. All right, so we're going to dive into one last thing related to Instabread, a little bit about how all this works. So similar to what we saw before is any of the sensitive data that we're collecting from the front end is essentially going directly into the vault. And through, it's basically SDK integration on the front end, but you can also do this directly with APIs. And essentially, the vault becomes the single source of truth of all this information, and the vault sends these tokens back to the front end application that we can then safely store downstream. Or we can also use those tokens to safely communicate, in this case with Moov or the HubSpot, like you saw, any third-party API. And again, that's just a simple API call. Then we're going to pass those tokens downstream into DynamoDB, like we saw, and this starts our ETL process. So I have a Lambda function set up in AWS that essentially is listening for any new records written into DynamoDB, taking that record, writing it into a Kafka broker, and then essentially the Kafka connector for Snowflake is being used to push that data down into Snowflake, and we end up with those JSON records like we saw within Snowflake, where we can now run our analytics or we can do whatever else that we want to do with that data. So we've been able to create essentially this very modern system, still fairly simplistic, but this is kind of the baseline for what most modern systems look like, all without essentially touching any of this data. And we've de-risked this whole surface area. So this whole idea that we talked about at the very beginning of essentially moving beyond privacy by design to privacy by engineering is really about thinking from a first principles standpoint of how do we manage sensitive customer data and essentially separating the world of data into different buckets, just like we do with these like personal physical documents, whether it's a diamond or cheese in my example, or whether that's my daughter's birth certificate versus batteries. I essentially, in the real world, I understand fundamentally that these are different objects. And we need to be thinking about that when it comes to the digital world as well and the management of customer data. And as long as we think about that and we essentially architect systems with a data privacy vault built in, then offloading things like data security, compliance, data privacy, and even things like data residency, which we didn't have a chance to get into, becomes as simple as a handful of API calls. And that, as an engineer building systems, that's a huge relief, I think, because I don't necessarily want to take on those challenges and those responsibilities versus essentially getting paid to build the features that generate revenue or are of interest to me as an engineer or as an entrepreneur. All right, so I want to, there we go. I want to thank you very much for listening to me. I think we probably have some time for questions, but if you are interested in these topics around privacy, security, you can check out a podcast, Partially Redacted, I host at skyflow.com/podcast, or you can look it up in your favorite podcast catcher, or you can join the community at skyflow.com/community. You can always contact me on LinkedIn or via email there, and I think we have some time for questions as well. Thanks. Anyone have questions? All right. While you think of questions, I'll filibuster for a minute. So I think one really common question that we get, or I get all the time when I present or talk about this is, this sounds great, but how long does this take to actually integrate? And of course, it depends on a lot of things. It depends what you're doing. But from essentially the customers that we've seen people go live as quickly as under a day, depending on what the use case is, to of course longer cycles. It depends what you're ripping out and what you're trying to do. But I think in comparison, basically, if the choice is I have to do something because I don't want to suffer a data breach, or maybe I did suffer a data breach and now I need to do something, or I have a compliance issue that I want to offload. The difference between taking on that challenge yourself versus doing something like using a Skyflow data privacy vault, you're going to haircut that significantly. And I think a lot of our use cases in the world of what we're talking about here, fintech stack, have to do with payments and essentially owning that data so you can orchestrate payments wherever you want. That's a very simple bread and butter use case that people are up and running within days, hours. Very, very simple to do. Anybody have questions? All right. Oh, go ahead, sir.
Use cases are very obviously fintech centric.
Yeah.
And stuff, right? What are like general things that people use?
Yeah, that's a great question. So, yeah, I mean, I think like they were all like, who do you sell to? Like, well, any company in the world that has customer data, which is basically every customer in the world. So, I think like our core sort of use cases are split into the world of the PII, customer management. Then you have your fintech use cases that we talked about today, data residency. So essentially, certain countries in the world have regulations around like, hey, you're essentially citizens of our country or our region. Their data needs to live within this region, and any operations on that also have to happen in that part of the world. So countries like Germany, Singapore, Canada, India just came out with a law for this. So more and more countries have this. And essentially, the only other viable solution besides using something like data privacy vault is replicate your infrastructure in those places, which operationally is very complicated and very expensive to do. It's hard enough to run one data center, let alone like trying to run 10 at the same time. And then the last one would be around analytics. So we touched on that a little bit. It's like, how do I take Snowflake, Databricks, or any of these analytical platforms out of scope of having to protect my PII? Because even though those systems might have a lot of things built in, like from dynamic data masking to field level encryption, like eventually I need to get that data out somewhere. As well as if I need to manage access at Snowflake, but then I also need to manage access in my application database and my log files, like that becomes a huge nightmare to try to, like, how do you actually govern access across all those different things, as well as have a similar configuration in terms of level of access. So essentially, Susie in accounting having different level of access than Bob in customer support and so forth. It just becomes a huge management issue. But so to your question, those are sort of the 5 core use cases, and that I think essentially is like every company in the world at this point.
Yeah, it seems like a game changer if companies looking to expand internationally. So can you talk about which countries have like the governing laws and stuff baked in?
Yeah, so we can serve over 150 countries. So we have. So we pretty much like any major country we can essentially handle from a deployment standpoint and from a regulation standpoint. And then I guess the last, I failed to mention LLMs, which was something Anshu talked a lot about in the keynote as well, and the big challenge there again is like, how do I make sure that either PII or even IP doesn't end up in the LLM? And then on top of that, the more complicated thing is, how do I make sure that the right people see the right information in the right way when they're supposed to have access to that information? Awesome. All right, well, thank you so much.